right, so let's look at this book assignment. And then for number 1, it says, for which counting numbers n greater than 1 is there only one rectangle whose side lengths in inches are the counting numbers and whose area in square inches is n. So basically they're saying, okay, you know, you have this number that is greater than n, but it only makes one rectangle. So like if you think of factoring, like 12, 1 and 12, 2 and 6, 3 and 4, I can make, you know, this skinny rectangle. I can make one that's 2 by 6. I can make one that's 3 by 4. So I can make 3 rectangles. So they're saying, what type of number does n have to be where you can only make one rectangle? So if you think of 3, you know, 1 by 3, that's the only rectangle I can make. 5, you know, again, 1 by 5, right? So 7, right? 11, and these are prime numbers. So prime numbers are the only ones that have one rectangle because that's the only way they can factor is like 1 and 3, 1 and 5, 1 and 7, 1 and 11. So prime numbers are the only ones where you can just get one rectangle. All right, let's look at problem number 4. Let's see. Okay, so problem number 4, if we flip the page. Okay, so problem number 4, it says, given 792 is 2 cubed, 3 squared, oopsie, and 11. All right, it says find all the factors. Okay, so, and pretend like you can't use a calculator and you'd have to just, you know, kind of like, oh my gosh. So I could take 1 times all of these. So 2 cubed times 3 squared times 11. And for now, remember, you have to check through the square root. So if I think of what this number is, you know, like, for example, the square root of 400, right, is 20 because 20 times 20 is 400. So I have to check past 20. If I think of, let's see, 30 times 30, right, the square root of 900 would be 30. So let's see, about square root of 625 is 25. So I know that. So somewhere between 25 and 30, you know, I would have to end. And so if I don't know what I'd have to end at, I could take, like, say 28 times 28. What is that? 16, 17, 18, 19, 22. Put a 0. What is that? 56. 784. So I'm guessing 2829 is going to do it. So I'm just going to go ahead. And I went through 13 there, and then we'll come, I don't know where we're going to find space here. I'm going to have to write smaller, I think. So 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and then maybe 24, 25, 26, 27, 28. And if we had a calculator, we could just take the square root of 792. So if I had a calculator, I could just take second square root, 792, and it says 28. So I can, you know, figure it out myself, or I can use a calculator. All right. So again, this is the DNA of your number. So do you see how 2 is one of the factors, the prime factor? So I'm going to take 1, 2 away. I'd have 2 squared, 3 squared, and 11 left. 3 goes in here because it has a factor of 3. So then I'd have what? 2 cubed. I have this 3, one of them left, and an 11. 4 would use up 2 of these 2 because 2 times 2 is 4. So I'd have 1, 2 left, my 3 squared, and my 11. 5, do you see how there's no factor of 5 in here? And so if 5's not in it, I know 10's out, I know 15's out, I know 20 out, and of course 25 would be out, and then 30 if I did. Because you need a 5 to build those. I don't have one. 6, I have a 2 and a 3, so I'm going to take both of those. So 2 times 3 is 6, so there's what? 2 2's left. 1 of the 3's, and 11. All right, do you see how there's no prime factor of 7? So 7, you know, there's no way it can be a factor. But that also means multiples of 7. So like 14, 21, 28, because they have 7's in them, and there is no 7 in the DNA here, so I can't do it. 8 would be 2 cubed is 8, so the other guys would be left over. 9 would take my 2 3's, so 2 cubed times 11. 11, you can see it. It's right there. So 2 cubed times 3 squared is left, because if you divide by 11, that would be left. 12, I would need a 3 and a 4. So I could take a 3 from here and a 4 from here. So there would be what? 1, 2 left. And then if I used one of these 3's, there'd be a 3 and 11 left. 13 is prime, but it's not part of the prime factorization. So 13 can't work, and nor could any multiple of it, because 26 has a 13 in it. All right, let's look at 16. 16 is 2 times 2 times 2 times 2. I only have 3 2s. I can get an 8, but I can't get a 16. So 16 out, and so would 32 if I had one. 17 is a prime number. It's not part of the prime factorization. 18 uses up the 9 and one of the 2's, because 9 times 2 is 18. So there'd be what? 2 2's left, so 2 squared and 11. 19 is prime, and it's not on my list, so can't work. 22 is an 11 with a 2, so that would divide in there. So if I take the 11 and 2, there'd be what? 2 squared and 3 squared left. 23 is prime and not on my list. Let's see, 24 is a 6 times a 4, or 8 times 3. So if I use all of my 8 and one of my 3's, I'd have what? 3 and 11 left. And then 27 is what? 9 times 3, but notice, or 3 cubed. I can get a 9, but I need another 3 to get 27. So I can't do 27. Now again, if you want to know what these numbers are, you can multiply them out. So for example, like if you're like, well, what is that? That would be 18 times 44. And that would for sure work, because 4 times 11 is 44. Or this would be what? 22 times this is 4 times 9, 36. And they're guaranteed to work because I'm using the DNA to make these. So for example, 18 times 44 is 792. If I take what? 22 times 36, you know, that's for sure going to work, because what I'm doing is I'm using DNA of the number, which is prime factorization, to build all these. And so I know what genetic code is in here. There's no 5. Okay. There's no, let's see, there's no 17 in there. There's no 16 in there. There's an 8, but not a 16. And so again, I could multiply these out if I wanted to know specifically like what these were. But I'm just using the factors, the prime factorization, to build these without having to make the rectangles. All right, and then let's see what was left. Number 5. All right, so let's look at number 5 quick. Number 5 says, without calculating the number, so we have 19 times 23 plus 1. This is problem number 5. Without calculating the number, tell whether it's divisible by 19 or 23. Okay. So again, this is a rectangle or you could draw an array of dots, but that'd be a lot, so I'm not going to do that. But this is either 19 groups of 23, right? Or it's 23 groups of 19, right? So if I'm thinking of rows, I have 19 rows of 23, or I could say I have 23 columns of 19, right? Going this way. And so this one extra is not enough to make, if I have 19 groups of 23, that one extra is not enough to make another group. I would need another 23. Or if I'm viewing it as 23 groups of 19, this is just one single extra. Again, I would need 19 to add another group. So in all of these cases, so what's the question say? Without calculating, why is it not divisible? Because to be divisible by 19, I would have to have 19 sets of some number to have it be divisible by 19. Or I would need, 23 sets of some number to have it be divisible by 23. So, and then again, we have this number. But so for it to be divisible, it has to be that many sets of something or that many sets of something. So if I have one more, that's going to be like a remainder, right? I'm going to have one left over. And again, technically on this, if I had one left over, it wouldn't be divisible by 19 or 23. If I had 2 left over, 3 left over, 4 left over, 5, because I can't make another group. 6 left over, 7 left over, 8 left over, 9 left over, 10 left over, 11 left over, 12 left over, right? 13 left over, 14. These are all remainders. 15, 16, 17, 18. Now, notice as soon as I add 19, then suddenly I could say, ooh, I have 24 groups of 19, and that would be divisible by 19. Okay, so if I added 19, not 1 through 18, those would all be remainders. But if I added another 19, then suddenly I have 24 groups of 19, and then that would be divisible by 19. Okay, say I don't do 19. Say I skip to 20, still not divisible. 21, 22. Now, if I add 23, that's going to be down here. Then suddenly I'm going to have, instead of, it's up here. Instead of, 19 groups of 23, I'm now going to have 20 groups of 23 because I'm adding another set of 23. So again, that would be divisible then by 23, okay? So if I add 19 to this, then I have another group of 19. If I add 23 to this, I have another group of 23. Then it would be divisible by whichever one, we're talking about, either the 19 or the 23. But otherwise, you know what I mean? If I add 1, 2, 3, 4, 5, 6, those are all remainders because it's not enough to make another group of either of those numbers. All right, hopefully that helps with those 3. And again, hopefully you tried them on your own first and then, fix your errors and get that turned in.